Yeah, the other one. Okay. We're going to draw angles. I'm big into pictures, all that good stuff. Drawing angles. So we're going to draw. We're going to do some drawing. Grasso, you ready? Now, let's say that we're going to have to draw a 240-degree angle. Now, everybody's going to draw it the same way. It's not like we get points for being creative. Everyone is going to start here. And this is called the initial side. The initial side. Now, just like most of us, 99% of us in this world have two legs. Guess what? Our angle has two legs. And you'll hear me say the distance between two legs. So every angle that we draw starts here, and that's your initial side or your initial leg. If we are working in a positive direction, you are going to move upward. That is considered positive. If we are drawing a negative angle, you're going to move downward from your initial side, which kind of makes sense. Positive up, negative down. Okay? Some people say clockwise, counterclockwise, whatever you want to call it. Okay, so if I'm going 240 degrees, where would that be?
Bottom left.
What'd you say?
Sorry? Yeah, bottom left.
Bottom left. Now, we're going to have to get on the same page a little bit. This we're going to call 1, 2, 3, and 4. Those are the different quadrants. Quad cities, quadrilateral has 4 sides. So, if I count it out as I go, what degrees am I at now? 90 degrees. These are the what I call specials. 180, and this would be 270. If I went all the way around, it would be 360. Now, obviously 240 is somewhere in between. Are you going to be exact? No. But we can be pretty close. Yeah. And then this is called your terminal side. So this would be a 240-degree angle. What if I said, hey, let's do a 500-degree angle? First of all, here I'm going to start. Which way am I going? Up. 360. Anybody know what 90 more would be? 450. And this would be 540, so it's somewhere in between there. There it is.
Boom.
500 degrees.
Can you say that minus 360?
What's that?
Can you subtract something to get like to the final angle?
This is a 500-degree angle. We got to go around. It's sort of like when I used to play basketball. I'd go up, and they always called me Tupai, and you'll understand that here in a second. When I was a kid on the streets down at Peterson Park, we always played. I'd go up. I was coming to dunk, but I'd go. And I dunked that way. That was a 500-degree dunk right there.
Hey, we should watch the video of the guy doing the 720 dunk.
Ooh, yeah.
I've seen it. That was me.
Oh.
So, what if I said, hey, do a negative 50-degree angle? Everybody starts at the same location. But now, instead of going up, I'm going down. There it is. Negative 50 degrees. Now, here's a question for you. This is negative 50 degrees. Now, if somebody looks at that, and let's take this out.
Looks like a triangle.
What degree measure would you say that is?
300.
Close.
10.
310 degrees. Why?
360 minus 60.
Correct. If I went this way, all the way around to the exact same terminal side, that's the same as 310 degrees. They are the same. If these two are said to be coterminal, what did we call that end leg there? What do we call it? The terminal side. So if we're coterminal, like cohabitats, cohabitat, what's that? Not creating together. Paige.
Harmony.
Oh my gosh, I'm a little embarrassed.
Oh, I thought you smelled Jack.
No.
Not yet.
Do you just save it up to come in here and just share it with your friends or what? I mean, seriously, that's weird.
Every day. That guy, right there. Every day.
There's me.
Every day.
So coterminal means that, just like cohabitat means live together, Paige, not reproduce together.
My mom had one.
So, same terminal side. Same terminal side. Question for you.
You're at the 6-minute mark, Trip.
I was like,
Let's say I gave you 65 degrees and said, hey, give me a coterminal angle that's positive and a coterminal angle that's negative for that.
I'm gonna say negative 295. Negative 295.
A coterminal.
Negative 295.
Positive negative 295.
Negative 295. Good Bobby Gibbons.
Negative 295 I agree with. Positive I do not.
425.
425. Now think about it.
425.
I'm facing this
Minus
direction. I'm going to move in a positive direction. A full circle. What's a full circle in degrees? 360. Does everybody agree that I just did a complete circle and ended up exact same location?
Yes.
Doesn't matter if I go this way or this way. Complete circle puts you at the exact location. Same terminal side. So what we can say, here's a visual aid to help you. Here is a 65-degree angle right there. What if I went, same thing, correct? What did I do? I went 360 degrees plus 65 more. If I went the other way, I didn't quite go 360 degrees. So, what's the shortcut? Take your degree measure, add 360 to get another positive, and go the other way. Subtract. Done. Those are coterminal. Coterminal.
so like on a test or quiz, if you were,
I was
let's say, like,
I was feeling lucky.
give me the coterminals,
Shush.
give me the coterminals of like all these numbers.
I would, here's how I would address it to you. I would say, hey, give me a positive and a negative coterminal for, here, let's take a tougher one.
Well, do you have to draw it or?
Nope. 390 degrees, give me a positive and a negative.
30 degrees.
30 degrees is a positive, I agree. I need a negative. Negative 330, there's, you're done.
How did he get that?
He subtracted 360 degrees and he still was positive. There's one. And then he subtracted another 360. Got negative 330. It's the same location. Every time you do a 360 page, you're right in the same spot.
Why did he not add them?
Because it gives him another positive. He would add two positives. Just keep going. Keep circling. If you circle 100 times, you're right in the same location. You've gone nowhere. Now, when I was younger, I told you I played basketball on the Peterson Park basketball courts. It was well known throughout the city of Davenport. There were some really good basketball players. Paul Dorfeld came out of there. He played at Iowa State. Troy Mullenberg, he played on the NCAA Sweet 16 UNI team. He came out of there. Golly, there's lots of people. But I was not a basketball player. I was a fouler. I usually got chosen if there was only 9 guys. That's the only time I got chosen. But you always take a break halfway through. Get a Gatorade or get a water or what? We called it halftime. So we always had a dunk contest during halftime. And my dunk that I was famous for was a 360. Now, I ran around with some guys that were kind of math geekish. So instead of calling me by my nickname of 360, who would call you that? Hey 360, that's weird. My nickname was 2Pi. Yeah,
2Pi?
2Pi. Just like it sounds. 2Pi. Now, I'm telling you right now that they could have called me 360. But they called me 2Pi. So what am I telling you? They're equal. Absolutely. This is 360 degrees. Anybody know what 2Pi is called? I'll tell you.
628.
This is radians. Now think about it. Radians. What symbol do you see? Pi. When you think of pi, what are we talking about? What shape?
Circles.
Circles. Circles. Isn't this a circle here?
I would say so.
So guess what, ladies and gentlemen? You are going to have to go and be able to convert from degrees to radians and also radians to degrees. We're going to use them both a ton. But anytime you're dealing with a circle, what do you guess we're going to use? You are going to use radians. Radians will always have pi in them. Radians will always have pi in them. Say it.
Radians will always have pi.
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 You know where pi came from? Take the circumference divided by the radius. So, ladies and gentlemen, if I say, hey, 30 degrees, what is that in radians? It is a simple process. First of all, what did I say that you have to have with radians? Pi. So, here's the shortcut. 30. You're going to multiply by pi over 180 to convert from radians to degrees. So you're going to multiply by pi over 180. Now, if you're halfway intelligent, which all of you are, I'm guessing you know that 30 goes into 180 how many times? 6. So guess what 30 degrees is equal to? Pi over 6.
Wait, how do you get the 180?
Well, we said that 360 was equal to what? 2 pi.
Oh, so it's divided by 2. Yeah.
So 180 is equal to,
I don't
Pi.
understand that.
Yeah,
How is pi equal to 180?
well, 2 pi is 360.
So 1.
I don't understand. Would that only be like 6?
What is pi?
Pi is 3.14.
So how is that times 2?
Because how do you find the circumference of a circle?
2 pi r.
2 pi r. What's my radius? We're assuming is 1 here. Okay? So, if I draw a circle with a radius of 1, and I go completely around, I take 2 pi times 1. That's a full circle. Agree? Well, what's a full circle in degrees? 360. There's where it comes from. So halfway around would be 180, or pi. So by multiplying by pi over 180, that's basically multiplying by 1. The same thing. We're just converting. What about 135? 135 degrees. Anybody know what divides into 135 easily?
135.
Well, yes, that's true. But that we've been using over here with our specials. 45. How many times does 45 go into 180? Well, think about it logically. Do you agree there's two 90-degree angles in 180? Do you agree there's two 45s in each 90 for a grand total of? So, 135 degrees would convert to 3 pi over 4. Now what if we want to work backwards? What if I said, hey, I want to know what 5 pi over 4 is in degrees? What do we do here? Multiply by 180, or pi over 180. What would you guess here?
220.
I got to get rid of my pi to get degrees. Wesley?
180 over 5.
Just flip it. Yep. Look what happens. So, if you're going to go this direction, you're going to multiply by pi over 180. If you're going to go this direction, let's change colors. You're going to go this direction, you're going to multiply by 180 over pi. Last thing is formulas. We'll review. You've worked with formulas before. How do you find the perimeter? Perimeter of a square. Of a square. Add all the 4 sides, or 4 times 1 side. That's a formula. Hey, what's the formula for circumference? Pi times diameter. That would work. Or 2 pi r. Same thing. These are formulas that you've used in the past. Why did I put a division? I don't know either. Now, what if I just, this works with a circle. What if I didn't want to find the whole circumference? I just want to find from here to here. I just want to find this distance. Now, a lot of you in the past used a proportion. That's what you used last year in geometry. I'm going to tell you a quick, easy way to do it. All you have to know is the radius and the measure of the interior angle here. Now, we are working with circles, correct?
Yeah.
With circles, what was mentioned? What must you have all your degrees in? Not 360. Radians. So, this is called an arc length. It's the length and it's an arc. Arc length is represented as S. I don't know why. We know R is radius. And you're going to see this symbol a lot. This is theta. And this is your interior angle, and it must be in what? If there's one thing that you get out of these formulas, you've got to have it in radians. It must be in radians. So if I tell you that this is 135 degrees, what's the first thing you're going to have to do? Change it. And we've already done that to 3 pi over 4. So, to find the arc length, you're going to take the radius times theta. So if the radius is 8, I don't want to do 8. Radius is 3. You're going to take 3 times 3 pi over 4. Now, a lot of you try to make this real difficult and use your calculator way too much. What's 3 times 3?
9.
That's how I want it, right there. Keep it simple.
You don't have to.
Keep it simple.
Is the arc length emphasis blue?
Yes,
The big part, like the circle on that side?
this part. Arc length goes on the arc.
Yeah.
Okay? Now, the other thing that we'll talk about with this is the area, this shaded area, region. It's called a sector, area of a sector. Area can be found by 1/2 times radius squared theta. One half. The radius would be 9 if it was squared. Times, what must this be for sure?
There. You got
Multiply straight across. 27 pi over 8. Don't make it difficult. Keep it simple. Keep it simple.
So maybe it's just like radians.
Yes, in radians. Once we start using Greek letters, we're talking about radians.
Will we,
A lot of the time, I should say. With a circle, let's simplify it. With all circles, we gotta have radians. We're talking about pi.